dugsiga boardingka iyo maalinlaha ah ee Amano boarding and day.
Assalamu alaikum warahmatullahi wabarakatuh. Welcome from Force. We will continue our usual classes. This is mathematics video lesson 3. We will start today. We will continue our previous lesson, which was random experiments. Let us start our lessons today. Okay, this is what we consider the probability of an event. Probability of any event. Probability of events. Probability of an event, it was said that we can use this formula. Then as we did it from 3. The number of favorable outcomes divided by the number of all possible outcomes. Or we can say that the probability of an event, P of E, it is the required outcome divided by total possible outcome. It means that if we roll a die, it has 6 faces. Therefore, the total possible outcome is from a die is 6. If you are asked to find the probability of getting 4, the required outcome is how many sides we have 4 on the die. It is 1 side. Total possible outcome is the number of faces that the die, it has 6 faces. Therefore 1/6, that's the required outcome divided by the total possible outcome. Okay, let's continue our examples from 4 book. This example, it states that a fair die is tossed once. If a die is tossed once, what is the probability that an even number appears? It means that what is the probability of getting an even number? Therefore, first we should think the event E is an even number. How many even numbers we have on a die? 2, 4, and 6. Those are even numbers from the faces of a die. And we have 6 faces from the die. Therefore, to find the probability of this event E, which is an even number, is the number of even numbers we have from the die divided by the sample space. The number n of s is the sample space. From here we can see that 3 is the number of faces the number of faces from the die that has an even number. 3 divided by 6. This 6 is the total number of sides from the die. If we simplify by 2, 1, by 3, 1, by 3, 2, this is the probability of getting a single roll from a die. If we roll a die once, the probability that we will get an even number, it is 1 divided by 2. 1 divided by 2. Therefore, the probability of getting any event is the required outcome divided by the total possible outcome. It means that if in a class there are 15 girls and 20 boys, if you are asked, if a student is selected from the class, then we are asked to find the probability of getting a boy. It is the number of boys. That is the required outcome divided by the total number of students. That is 20 divided by 35. Then you can simplify. In a box there are 5 red and 4 green balls in a box. If one ball is selected, then the probability of getting a white ball, it is the number of white balls 5 divided by the total number of balls, which was 9. That's 5 divided by 9. Okay, let's continue. Okay, from here, the probability of an event can be found by empirical method. The previous one, it was called classical method, because we have number of sides and the required, then we simply divide by required outcome divided by the total possible outcome. In this question, it deals with, this is called empirical form. Therefore, suppose if we are given that the die is rolled 10 times, a dice roll 10 times, and the results are recorded in this table. This is the score, this is the frequency, the number of times the die has 1, 2, 3, 4, 5, and 6. It was tossed 10 times. We are given that this one it occurs 2 times, 1 time, 3 times, 2, that is 7, 8, 1, and 1. Then you are asked to find the probability of getting 5. Probability of getting 5. That is the relative frequency. Relative frequency, it is the frequency from the table that we have 5. That's 1 time. What is the frequency of side 5? It is 1. Divided by the total frequency, which is 10 times. That will be the probability of getting 5. If you are asked to find the probability of getting 4, it is the number of 4 is that we have from the table divided by the total number of times. 2 divided by 10, you can simplify 1 over 5. This is the relative frequency, and it's called empirical approach. Empirical approach. Therefore, the probability of an event from empirical approach is the frequency of the event divided by the total number of observations. It means that the frequency of a certain number divided by the total frequency. The total frequency. From here, we have one example. If records show that 60 out of 100,000 bulbs produced are defective, it means that each 100,000 bulbs produced, 60 are defective. If you are asked the probability of newly produced bulb being defective, we will use the empirical approach. It means that the frequency and how many bulbs are defective. The defective bulbs are not working bulbs is 60 out of 100,000 bulbs. Therefore, the probability of getting a defective light bulb, it is the frequency of the defective light bulbs divided by the number of a total number of bulbs. 60 divided by 100,000, which is 0.0006. Therefore, from the empirical approach, the probability of that we can find a number an event is the frequency of that event divided by the total frequency, as we did from this table. Okay, let us continue. Okay, this is axiomatic approach. Axioms. From probability, we have axioms. What are those axioms? Look, the probability of any event might greater than 0 to 1. It is in between and greater than or equal 0, less than or equal is 1. That is the range of probability. The range of probability. There is no probability of an event which is bigger than 1 and less than 0. That is one axiom or one postulate from the rules of probability. The sample space. If you add all the probability of a given an event or a sample space, it always 1. It goes to 1. Look, if you are given the probability that you will pass an exam as 0.25, then the probability that you will not pass the exam, it will be 1 minus this one, because there are only 2 possible ways. Either you will pass the exam or you will fail. If you pass the exam 0.25, then it goes that the probability that you are failing is 1 minus 0.25, which is 0.75. If you add these 2 probabilities, which is the sample space, we have 1. Therefore, if you add all the probabilities of a sample space, it's always 1. Look here, you have 2 events, E1 and E2. They are mutually exclusive events, as we did it earlier. Mutually exclusive events, it means that if the 2 events, they cannot occur at the same time, they are called mutually exclusive events. Look, rolling and tossing a coin, we can get head or tail. They cannot occur together at the same time. Therefore, these 2 events, they are mutually exclusive events. Therefore, it is called all rule or union. Probability of getting E1 or E2. It is the addition of their probabilities. It is the addition of their probabilities. If we are asked to find the probability of getting head or tail from a single toss of a coin, it is the probability of getting head plus the probability of getting tail. Therefore, probability of getting head is half. For the tail, we have half. If we add them, we will get 1. Mutual exclusive events means that two events, they cannot occur at the same time, and we will use addition law. We will use the addition law. Okay, let us continue to this example. This example states that a box contains 6 red balls. One ball is thrown at randomly. We select one ball from a box containing 6 red balls. Find the probability of getting a red ball. It means that we have n of sample space. You have 6 red balls. We are asked to find a probability of getting a red ball. Probability of getting a red ball, it is the number of red balls divided by n of sample space, which is the total number of balls. Therefore, we have 6 red balls, and the total is 6 red balls. Therefore, probability of getting red ball, it is 6 divided by 6, which is 1. It is very certain whenever we select one ball from the box, it will be red ball, because we have only red balls. Therefore, 6, it means required outcome. We have 6 red balls from the box, and we require to get red ball. Therefore, it's 6 divided by 6. Probability of getting white ball, B. Probability of getting white ball, it is the number of white balls divided by total number of balls. Look here, we have only 6 red balls. There is no white balls. Therefore, 0 white ball divided by 6 balls. It is impossible to get white ball from a bag which consists of 6 white balls. That's the probability of getting red ball. This is white ball, because we don't have white balls from the box. Only we are told that the box contains only 6 red balls. Therefore, there is no white ball. 0 divided by 6. Okay. Look this example. This is example. We will do it together. Look, which of the following cannot be valid assignment of probabilities? We have different probabilities of certain events. The outcome is of a sample space. This sample space consists of 3 events: W1, W2, W3. But we are told that any 2 events, they are disjoint. There's no sharing elements. They are disjoint. They are mutual exclusive events. If we are told that E1 intersection E2 equal is null set, it means that they are mutual exclusive events. They cannot occur at the same time. Therefore, from here, let us see. For W1, these are the probabilities of W1, W2, W3. Let us add for A. Probability of W1 plus the probability of W2 plus the probability of W3. It is more than 1. Therefore, A, it is not valid assignment, because it cannot be greater than 1. A is not a valid assignment because the sum of the probabilities is bigger than 1. It cannot be bigger than 1. Look here, 0.2, 0.5, it is 7. 0, it is 1. Therefore, number B, it is valid assignment because it satisfies all the axioms. What are the axioms? The addition is 1. There is no negative number. Those are the axioms. Look here, this one is negative. This is not valid assignment. It is not valid assignment because probability cannot be a negative number. So we will stop here, and you can continue more examples from Form 4, Somaliland Form 4 textbook. Assalamu alaikum wa rahmatullahi wa barakatuh.